Welcome back to DWeb Decoded, a podcast by Filecoin Foundation that explores the intersection of blockchain and the data economy. I'm your host, Aaron Stanley, and today I'm joined by Miguel de Vega, who's co-founder and chief scientist at Nillion, which is building a network for privacy-preserving computation. Miguel, it's great to have you on the show.
Yeah, thank you, Aaron. It's great to be here.
So to get us started, can you give us your elevator pitch on just what Nillion is? And then I'd love for you to give us your career background trajectory and how you came to work on this project.
Sure. So you can think of Nillion in terms of a new type of Web3 infrastructure. It's not a blockchain, but it sits alongside a blockchain, so it can interconnect with a blockchain. And what it does, what it enables is essentially the storage and computation on private data, but in a way that is actually better from compared to what happens in Web 2, where actually there's a company there which has the decryption keys to all your data and can actually see it in the plain text if they want to. Here, it's completely decentralized privacy we're talking about. So at no point do the nodes in the network actually have access to your data. And nevertheless, they're able to perform computations on your behalf. And you're also able to store your personal data all in a decentralized way. And so the way that I ended up doing this, essentially, I think the story began, I like technical stuff very much. So I studied telecom engineering, but then I also did a PhD in maths. Initially, my career back in 2000, I started working with large companies, working with, kind of trying to predict the traffic patterns in the big backbone of the internet. Came up with around 30-ish patents on that. I was very interested in big data because you have to collect a lot of information for that. And that took me to AI. And so that has been one of my passions. I did a few startups on AI. And then in 2013, I started getting very interested in cryptography. So in zero knowledge proofs in particular. So I started using them first for Web 2, for authentication, identity solutions, and stuff like that. But that was like the thing that took me into crypto, because as you know, ZKP is very strong in crypto. It's used in many places, like in the privacy coins. So in 2017, I met with Andrew Masanto. He's co-founder of Hedera and Reserve, and we were toying with the idea of creating a privacy coin. In the end, it didn't work. Masanto determined that it wasn't the time. He's got a very good sense for market opportunity. He thought that it wasn't the right time for this in 2017. But I did get hooked already with Web3. For example, I created my own trading bot and started trading with it. And I kept on working with privacy enhancing technologies. From ZKP, I went over to multi-party computation, MPC, and back in 2021, Masanto, myself, and a few others got together again, this time with a new idea, which is essentially the blind computer that Nillion is nowadays presenting. And that's how it started. Like, how can you apply multi-party computation to this problem of storing and computing on Web3 decentralized infrastructure, but in a privacy-preserving way?
Yeah, and this stuff is super interesting, and your background is super interesting as well, right? Coming into this, having worked on not only a lot on the startup side, but also working with big corporates and working on just entities that are using all these big data sets and whatnot. This is super interesting. And I want to dive into the kind of the nuts and bolts of this idea of blind computation. But before we do that, I think it'd be interesting to kind of fast forward to like the end game here. And you guys have presented this idea of like personalized AI. And basically you've kind of presented this idea, and you're kind of talking about how Nillion and blind computation can essentially enable this. So I was hoping you could maybe walk us through, like, what do you guys mean by that term, and why is it significant?
Yeah, that's a very good question. I think it's a very good example that illustrates the importance for privacy in Web3. So essentially, the notion is that as AI becomes more and more complex and intelligent, it will tend to actually learn about you so that it can provide you with a better service, essentially. So it's now run out of public data to train on. The next frontier that will enable it to be really, really helpful is when it gets to know you like from the inside out. It actually becomes your virtual clone, if you wish. But for that to happen, you have to go and share what we call the level 3 of your data. Now, level 1 is fine. Essentially, it's everything that you put out there that is public. For example, this podcast and the tweets you send, and everything that is actually public domain. Everything that a journalist doing an article on you would actually have access to. Level 2 is what we're currently sharing with Web2 companies. It starts from your browsing history and cookies, and it depends on the service you're consuming, but you're sharing a lot of information actually. And you know what? People are fine with those two things, right? We've been sharing that information with companies already, like for a long time. There's been problems with hacks and disloyalty from companies. I'm thinking about Equifax scandal or Cambridge Analytica, but altogether people seem to be kind of okay-ish with sharing that information. But here we're talking about something different. When it comes to AI and this new form of personalized AI, which I think is what AI will progress towards, we're talking about everything that makes you you. So the things that you would only share maybe with your therapist, the things that you really think about people, like your boss or your mother-in-law, because think about you will constant conversations with this personalized AI, and so you will be sharing almost everything with that agent. We're talking about all your messages, accessing all your conversations. We're talking about your medical records. We're talking about this agent learning the limits of your intelligence, your cognitive biases, how intelligent you are versus how you think you are, how smart you think you are. All those things, when you put them together, it gives the company running that AI actually a lot of power, like an unprecedented amount of power over us. And not just power to share that information and trade on it, but actually the power to influence us in a way that maybe we wouldn't be able to identify or to detect. That's very scary, and that calls for a special type of technology. So we advocate for the transition from centralized AI run by a handful of companies towards what is known as decentralized AI, but with a very strong privacy component. I don't think that there can be decentralized AI without privacy. It has to be a core ingredient, because otherwise all that information, all those sensitive data points would be public on a blockchain. And yeah, like you were saying, this is a very illustrative example, I think, of the importance of privacy in Web3.
And I like this taxonomy of the different types of levels of sensitivity of data that you've created, right? Where you have, kind of level 1 is just like your Facebook posts and whatnot. Level 2 is like, okay, this is maybe your cookies and like your browsing history and maybe your location data or something from your phone. And level 3 is the stuff that you really don't want people to know about unless there's a really good reason, right? Yeah. And I feel like it's helpful. I've never really heard anyone like kind of break it down like this before. And I just found this taxonomy really helpful, because in Web3, we do kind of had this chicken and egg problem almost, where people are like, oh, we want to build more privacy preserving apps, or when is privacy going to be native? But at the same time, like most consumers, they don't really care, right? Like we keep using Gmail, we keep using all these things. It's like, I don't really care that much if my, like my Twitter posts are like, being used for hoovered up for something. It's not a huge issue to me, but like my medical records or my tax records or my bank statements, like, okay, I do care about that. Right. So, but then if you're going to build like a real, truly personalized AI that has any kind of value to it, you would need that level 3 sensitive data. Otherwise it's not going to be, but people don't want to just turn that over to, Sam Altman or to Google or whomever. Like that's kind of crazy. Right. So
that's crazy. That's very scary.
So it seems like what you guys are doing here is really like kind of the missing link between bridging all this stuff, right? So I'd love to dive into just what you guys mean by blind computation, and from what I understand of at least from what it means, is that you're basically able to run compute jobs over encrypted data, right? Where normally encryption, as it stands right now, is usually if the data is at rest or if the data is being transmitted, that it can be encrypted, but in order to actually run a compute job over the data, you need to unencrypt that data, right? But you're proposing a way by which you can run compute jobs over the data while it's still encrypted.
Exactly. Essentially, there are 3 things you can do with data. I mean, you can store it in encrypted form, you can transfer it also in encrypted form. That happens with TLS and HTTPS. But if you want to process it, if you want to do things with it, manipulate it, then you need to decrypt it first. That's the problem, the big problem with Web2, and the reason why companies do have access to your information, even though they claim that everything is encrypted and all of that. In the end, they have to have access in plain text to your data so that they're able to provide you with a service. So that's what we're solving for here. So we are combining what's called different privacy enhancing technologies, which solve this problem from different angles and kind of produce different points in the trade-off space between security and performance and utility and usability. And we're doing that so that developers now, Web3 developers, can develop applications that can store information on decentralized infrastructure while maintaining its privacy. So it's different from the Web2, encryption at rest, because there, again, you have the keys to decrypt it. But here, the nodes in the network, they don't have access to the data. They are just keeping encrypted versions of it, or depending on the flavor of PET, of privacy enhancing technology. But essentially, they're getting things from the data or byproducts that don't reveal anything about it. And they don't have the ability to decrypt it. And then developers are also able to actually run computations on that data without decrypting it. And that's why the nodes in our network, we say that they're blind, because they're able to perform those computations and store that data, but actually without having access to it.
And can you walk us through a bit how that data is actually transformed, then particleized, and then like how the nodes are able to run these compute jobs on these particles without like knowing what the actual contents of the data is? And I guess lastly, like how does that all get pieced back together where you're able to sort of put the message back together again, like putting together Humpty Dumpty, I suppose, after he fell off the wall. Yeah. You have to kind of put it all back together at the end. And I know you're obviously like PhD mathematician, cryptographer, but maybe kind of explain in like layman's terms, like how does this actually work?
So as I was saying, we are combining different privacy enhancing technologies. I think the two main ones here of interest are the fully homomorphic encryption primitives and then the multi-party computation primitives. Although this is a little bit tricky because actually FHE, or fully homomorphic encryption, is a building block towards MPC. So you can, let me explain it then that way. So we're using MPC, and there's different ways of doing that. One that is through encryption, through FHE. The other one is through shares, and I will explain what that is. There's a third one, which is through garbled circuits, but that it has like more limited applications. So let me focus on the first two ones. With encryption, the analogy would be that of putting your secret inside of a box, so that it's hidden, and nevertheless being able to do stuff with that secret without opening the box. So if your secret is a number, and I have another box with another number, I can add those two numbers, but magically without opening the boxes and looking into the numbers. And that's done by operations on the ciphertexts, on the encrypted version of the secrets. And then in the end, when you're done with all those operations, you decrypt the result, the kind of output from the computation. With MPC built from shares, the analogy looks more like a shredding machine, where you put a piece of paper with your numbers, your inputs, and then you come up with these shreds of paper that you distribute among different nodes. And then those nodes somehow, following this protocol, are able to, from these shreds of paper, which don't reveal anything from the secret because they're really thin and they're just noise, they're able to actually perform computations on the actual inputs by communicating between themselves. So they're sometimes messages, sometimes doing some computations, and in the end they come up with shares or shreds from the result, so that when you put all those together, you actually come up with the output from the computation. So Nillion, you can think of it in terms of what we call an orchestration layer, which is an architecture that enables you to combine different PETs, different flavors of multi-party computation and other cryptographic primitives, so that it opens up the space for developers because they are no longer restricted or kind of limited by what a given PET can do, but rather they can combine them in a seamless way to address more use cases and applications.
And that's super interesting that your end game here is this orchestration layer that you mentioned, where you're you're combining these various privacy enhancing technologies, MPC, FHE, zero knowledge, to allow developers to basically build like natively private applications, right? And
yes,
and I think a lot of these technologies, like just by themselves, don't necessarily like facilitate that, right? Like a lot of people in crypto are like, oh, I'm using zero knowledge or whatever, or I'm using MPC, but like just like these things by themselves don't necessarily facilitate like a natively private application. But you're basically building kind of this orchestration layer where you can, as a developer, you can kind of pick and choose. Okay, for I'm going to use MPC for this, use ZKP for this, and we'll have it just integrated into from basically the bottom of the stack of the application.
And even that is one of two steps. So step number one is the combination of these different privacy enhancing technologies, but the end result from that is a very low level programming interface. So you can think of it in terms of almost like machine code. Like it's very hard to program on that, right? And as a developer, you need something that is higher levels, closer to your domain of application. So the second step is building libraries or kind of functionality that bridges that gap between this low-level functionality that PETs provide you with and what you really need as a developer. And to give you one example, in the domain of artificial intelligence, we have developed what we call the AI VM, which is it feels and looks like PyTorch. So essentially, if you are an AI developer, you're familiar with that. But under the hood, that's actually implemented with these lower level primitives, the PETs, so that you're playing just with models like you're used to. You're running inference or doing other things, but actually everything is running under privacy preserving technology. That's the ideal scenario for a developer, we think, because it doesn't force them to, it doesn't require them to learn these difficult cryptographic primitives. It doesn't even require them to actually choose between them. This library is actually making those choices on their behalf, and it's able to do that because it's focusing on one domain of application, and so it optimizes everything.
Got it. And I know you've had a few integrations recently with some notable chains like Near and Arbitrum. Fairly, I think these were within the last couple of months, but maybe talk a bit about, how could a builder on Near, a builder on Arbitrum, utilize this orchestration layer?
Yeah, absolutely. Very good question. So far, we've kind of talked about the Blind Computer as a standalone thing that you can use. And sure, I mean, if you're a Web2 developer, now you can have this Blind Computer help you build on decentralized infrastructure and with the same look and feel, right? You're able to store private information and all that. But what does it mean for Web3 developers? So we've, as you said, we have partnerships with a few L1s and L2s like Near, Arbitrum, Aptos, Say, Ionet, Ritual, and others. And what it looks and feels like is we can read and store or write on blockchains essentially through smart contracts. For example, we can listen to events that happen in all these different blockchains, and then we can perform some computation on private inputs or inputs that may be coming from the smart contract or combinations of the two in a privacy preserving way. And then when you get the outputs, you can write them back on the smart contract. And we do that using threshold signatures. So again, it's a decentralized protocol that enables all the nodes in our network to jointly sign a transaction that is then consumed by smart contract. So it's seamless integration with Web3 blockchains. Actually, there's another level where blockchains are useful for Nillion, which is that we are also consuming internally our own blockchain, which we use to run the coordination for this orchestration layer. So there's a need for every single cluster in the network to be coordinated, and that is done through a blockchain. And also, by the way, this blockchain is the one that runs our token. So you have like these two connections to blockchains. On the one hand, we have our blockchain, which runs on Cosmos to do token and coordination. And on the other hand, as a developer, you're now able to we're actually writing the integrations with these different blockchains, but you'll be able to actually write and read, do those read and write operations with the Nillion infrastructure.
No, that's super interesting, and I'm excited to see like what types of applications people were able to build, kind of using this infrastructure on these various chains. And I know, especially with the Near. I mean, the Near integration is particularly interesting. It's just because I know Ilya with Near as, I mean, this is sort of his background is building AI languages and applications and things. So they've always kind of had a really strong bridge with the AI and data world,
exactly,
in that particular ecosystem. So it'll be super interesting to see what comes out of that. And maybe stepping back a little bit here, I wanted to ask, how do you see Nillion fitting, or this concept of blind computation, like fitting into this kind of this debate that we've had on like data privacy versus utility that we've had in you know, particularly in the last couple of years with the rise of LLMs and stuff. I mean, are you basically saying that like blind computation can like enable you to have both of these simultaneously, both privacy and utility?
Yeah, we think that privacy is non-negotiable. Is not a nice to have, is a must-have feature for the reasons that we covered before about level 3 data and in general for Web3. So we do acknowledge the fact that if you, number one, introduce a decentralized network like we have, number two, if you put privacy on top of that, there's a price to be paid in terms of performance. However, we do think that the flexibility that, you know, toying around and playing and combining different privacy-enhancing technologies will give you. I think that flexibility will enable you to meet your requirements in terms of the, you know, combo between performance and security. Just to give you an example, we are also combining the use of trusted execution environments, which are nearly as fast as plain text computations. I mean, the performance penalties are somewhere around 10%. But of course, they do provide a lower security model than the, you know, kind of harder software-based cryptographic primitives that I've been talking about before, like multi-party computation. But the bottom line here is that there should be no excuse to actually use or you know, like build with privacy first in your mind and in your head. There's no excuse for that, because you will be able to find you know, the right balance between privacy and security. So it's not a question of if, it's a question of where do you want to have privacy? To what extent do you need to have privacy versus speed? And I think that's a very important distinction. And I think there's a lot of interest in the kind of more traditional Web2 companies in making us believe that sometimes privacy goes against innovation and technology. And that is something that you have to give up if you want to be using the latest technology. This, in this case, is AI. But that is definitely not the case. That is obviously in favor of their business models and their reasons for that. But there's no technological reason to, you know, in our view, to kind of justify sacrificing privacy in favor for something else. There's just no reason.
Yeah, that's super interesting, and I like this idea of even challenging the premise of that debate, right? Where like there's no reason you can't have these two things, like technologically you can't have these two coexisting, right? The utility and the privacy, and it's sort of a false construct that's been created by folks who benefit from having users voluntarily give up their privacy, basically.
And they've done a great job. I mean, they've done a great job.
they have done a good job at it. Yeah, we got to give credit where it's due, right?
Exactly.
They've done a pretty good job at it. So, and maybe as a way to like help just myself and listeners better visualize all of this, could you talk about maybe it's just some types of use cases that blind computation could unlock? Like what could this like actually look like? What could an application like this like actually, or that uses this actually look like?
Yeah, so we're really excited. We're working with what we call FEs, founding entrepreneurs, and what we're seeing them build is we're seeing kind of a number of patterns. So one is around data. Is that what we call data blobs? Essentially, is people or users they submit data and they store it in our network. So that's one side of the market, the supply. And then the demand side is third parties who wish to either pay those users in some way or form, or to grant them access to their services, for example, insurance applications or things like that, in exchange for getting insights from their data, but not the data itself. And of course, everything runs with permissions. So there's a lot of applications on that that are building. There's a lot of founding entrepreneurs that are building those applications, and it's really interesting because it covers like a lot of verticals, like healthcare, and biology, like research. Like there's a lot of different verticals there. Then one of the other things that we're seeing a lot of interest in building on Nillion is AI applications. So for example, we have people building marketplaces of private agents, so that you can choose your agent, and there's maybe one agent that specializes on, financial advice. There's another one on accounting advice, another one on medical advice. All of those very sensitive topics, as you can think. And then the idea is that you build them on top of Nillion so that you can preserve privacy from user prompts, and sometimes even from the weights of the model if they're kind of private as well. Then we're seeing also interest from games, Web3 games, where you want to store the state of the game in a privacy-preserving way, and also generate it in a way that prevents the company creating the game from taking economical advantage of the fact that they can control the code. Because in this case, everything runs on our decentralized network, all the random generation and the shuffling and all the key functionalities is running there, so that you cannot collude, you cannot tamper with the integrity of that part of the service, which is important for games. And another one is DeFi. So we're seeing people building decentralized exchanges, which are private, so that you don't see the asks and the bids. Everything is private, but the matching is taking place nevertheless under PETs. And then you're able to run the decentralized exchange. So almost every vertical that you can think of in Web3, for example, also the DeSci, decentralized science, is also very interesting. Almost every vertical is touched, or you can kind of can direct it more towards end consumers and retail, because now you're able to process their information with privacy guarantees, which is something that before it wasn't possible. So it opens up the space, the design space for Web3 applications, and it also kind of brings Web2 into Web3. So some of those FEs, founding entrepreneurs, are actually coming from Web2. And it's very interesting to see the differences between the two types. The Web2 types, usually they're better at UI. So they really care a lot about UI, and they also care a lot about product market fit. But the Web3 people are maybe more more tech savvy, and also like backend kind of people. They understand crypto better. So it's very interesting to work with these two different archetypes of developers. And it's very interesting for us to be in the middle, trying to put them together. And actually, we see teams where you have a mixture of Web2 and Web3 developers doing the same thing, the same application. And I think that's very promising, because one of the dreams that I have, at least, is to be able to unlock the potential of Web3, which I think now is constrained by the inability to process private data, and to actually let it expand into kind of more Web2-ish use cases, if you wish, which is something that was tried in 2017. It didn't work. Probably one of the reasons was privacy, but I think there's a lot of potential in doing that. Yeah.
Yeah, so many interesting angles to take this conversation from here. I guess one use case that I was thinking of as you were just talking was with banks, right? You have banks with anti-money laundering. They're supposed to be talking to each other. They're supposed to be like sharing information, but like at the same time, they also have to comply with like Bank Secrecy Act and like local data protection requirements. And these are basically two like totally contradictory things that they're supposed to be complying with.
Absolutely. It's a great application.
And, and it's just like, wow, like this really does open up a lot of like a huge design space, like you were mentioning. And I guess my question would be, so how, just kind of going back to like, how do the network actually works? Like what's the incentive for the node operators what's the incentive for somebody to become a node operator, I guess? Is this where the token comes into play? And then I guess like how do you scale this, right? I guess would be the kind of the follow-up question to that. Like
Yeah, very good questions. Everything has to runs on token incentives. I think there's no other way to build something as big as this if it were not with a token and with Web3 technology. So you have different players. You have verifiers, which verify the integrity of the secrets. You have node operators for the blockchain. If you remember, I mentioned that we were using Cosmos, so for that part of our infrastructure, but also for the blind computer. We also have all these founding entrepreneurs. We have the partners. We have the larger community of cryptographers and so on. So there's a lot of players and actors in the space, and all of them need somehow to be incentivized. Sometimes it's through the token, sometimes it's through just mere collaborations. But in particular, regarding your question, the node operators get incentivized through tokens. And the way to scale this up, I think it's an interesting aspect of this technology that differs from blockchains. So in blockchains, the analogy is that of a monoprocessor. So you have just one CPU because everything has to go through this global consensus that happens in the blockchain. Even if you have like L2s and so on, everything in the end has to be settled on the L1, and you need to go through the consensus. The architecture of the blind computer is different, is one of different clusters, where the clusters are pretty much independent from one another. So it resembles more like a multiprocessor architecture, where these clusters are able to function in parallel and compute in parallel, and they don't need to run consensus across clusters. They just need to do internally this consensus. So the natural way for this network to evolve and scale up is actually adding more clusters so that they are able to meet higher demand. And that is actually a better situation than the one you have in blockchains, because adding more nodes in a blockchain actually makes it more difficult to run consensus. In this case, because they're independent, it's not the case. So it is in that sense a network that naturally scales up very well.
Well, that's super interesting, and I guess it's worth pointing out that the function of the nodes here is not storing an entire transaction history of the ledger, right? Where you would have in a traditional blockchain network, right? So there's not necessarily, like, obviously once this, if you're storing the entire Bitcoin ledger, the entire Ethereum ledger on your node, that's there's quite a lot of these are big ledgers now, right? So like the nodes can focus on just the computation and not necessarily like trying to maintain the state of the network and that type of thing. So it's less of a
that's a very good observation. There's not a data structure that is growing and growing and growing, but rather there's just computations and data that you need for those computations, and that's what the nodes are concerned with.
And then maybe to wrap up here, just kind of one big picture question for you, but like, how does the ability to offer private computation, like you guys are trying to do, like, how does this fundamentally impact like the value of our data, right? We've kind of been alluding to this question, I think, over the course of this conversation, but what does this actually unlock? And how does this fundamentally like impact like my personal data and the value of my data?
Yeah. I think it essentially unlocks the value of your data. It is the new gold in our era. Companies, again, are maybe trying to keep that quiet, but they've been exploding our data and utilizing it for their own purposes and interests for a while now. And that's just going to be even more so, right? In the future, with AI now in particular, our data is going to be one of, if not the main asset that we have. And so what this technology enables you is to actually be in control of that data. It puts you in the center of it. It relieves you from the kind of burden of having to directly deal with it, because, of course, one alternative solution would be that you store everything in your client, like in your computer. But that's like a bad idea, because it's a lot of responsibility for you to have all your keys there, all your medical records, personal information. This is a better solution because it allows you to kind of put on this decentralized network all your data. You can control it. So you can, whenever you want, you can compute on it, or you can let others get insights from it, but you get to know which computations are being run on it. Whereas now who knows what computations are being run on our data on Web2 servers. And it also opens up the monetization ways for you to actually gain some value from that data. So I'm talking now referring to data to earn, where once you put that data on our network, actually third parties will pay you to be able to derive or extract some insights from your information. So again, this revolves around the notion of you being in the center of control, and also making, profiting from this amazing asset that is our lives and all our data and everything, all our history, medical history, financial history, all our interests, our dreams, the things we work, our ideas, all of that has a lot of value and is unique and is what makes us us. And so, I think privacy and in general, and this technology in particular, is giving to this the right amount of value that it deserves.
Amazing. Well, Miguel, this is super interesting stuff. Congratulations on everything you guys have built so far. This is really kind of mind bending. I'm trying to think of a better adjective, but it's just kind of really mind bending. But no, where can folks go to find you if they want to get in touch or learn more?
Yeah, so there's different channels. Probably the best one is if you go to Nillion.com, you will find there, number one, the X account. That's a very good way to, kind of get to know us a little bit better. But also we have a Discord channel. That's probably even a better way to get to know us directly and to be able to DM us and actually start a conversation. And we're always open. We're all about the community. And so we're more than happy to start a conversation with any of you.
Very cool. Well, Miguel, thanks so much for your time, and congratulations again. And thanks everyone for watching, and we will see you next time.